So yeah, hello everyone. It's really nice to be here today. So Distroless Docker containers for machine learning. I'd like to introduce myself a little bit. Recently graduated, got my bachelor's degree in computer science at Delft University. Currently doing my master thesis in data science at Delft. And I work as a machine learning engineer at ING Bank. ING Bank is a Dutch bank, but we operate globally. And this is my very first time standing here giving a talk, so it's quite nerve-wracking, but it's awesome to see all of you here. So what I'll be talking about today, I'd like to give some context. So what really does it mean to run machine learning in production these days? Some concerns about machine learning in production, and maybe some concerns about machine learning in general. And then I'd like to take you on a journey from a very simple model, and we'll gradually use Docker to containerize this model, and then finally make this image also distroless. So, machine learning in production. I think many of you have once made a machine learning model. Maybe some of you have gone the length to also encapsulate in some API and then expose this API so that you've got a service running, and whenever you send a request to this API, your model makes a prediction. This is awesome, and but at larger organizations, this becomes more of an issue. So if you've got many teams and many models all running at the same time, how can you really manage this? So we've got tens of, maybe hundreds of models all running at the same time, and each model has their name, and you want some uniformity here. So the way we solve this is making some kind of platform, a platform where data scientists can send their model, either this will be some Python code or some Python code along with their pickled parameters, and this will go down a specialized pipeline. And in this specialized pipeline, will outcomes rolling a Docker image we can run on top of the platform, and through some service discovery, we can reach the right model. Now, each of these models, they would run in their own environments. And this would be an excellent use case for containers. Maybe some models are made for TensorFlow. Some models may be made for Scikit. Containers are an excellent solution for this. Though there are some concerns about machine learning. And this is that machine learning models could or tend to handle quite sensitive data. Some of these features using in our models might identify people. And this is very, very concerning. So we really want to be more aware of where are we actually running our models. Are these containers we're using actually safe to run? And as much as we try to make data anonymous, this is extremely difficult. On top of that, a machine learning model itself can contain sensitive information. Think of parameters. Think of some word-to-vec model that has a dictionary mapping maybe a name to some feature, which is not quite desirable. So what I really want to talk about today is how can we make sure at least the environment in which we run these models to be a bit more secure instead of just taking a random Docker image. So our little model. I'll be using Scikit, Flask, and then of course Docker to take you guys on a journey in which we have a simple model and slowly build this model further, and eventually landing in a distroless Docker solution. So this is our little model. It's a random forest classifier. We use the iris data set, extremely exciting. So if you don't know what a random forest classifier is, don't worry. Think of it as a simple machine learning model. If you don't know what the iris data set is, just think of a simple data set. Now we use Flask to expose this. Now, obviously, in a production environment, you wouldn't really want to do it like this. You would do some validation. You would perhaps come up with a schema. You would use data frames as a way to communicate. You would use some libraries. But I want to keep things simple. So we do this instead. It's simply an API exposing the /predict endpoint in which we can post an array. And with this array, we can make a prediction. It works. Well, at least when I tried it, it works. If I use the curl, I would get back the prediction of our model. So let's Dockerize this. So we would start by picking our base image. In this case, we'll use the Python 3 base image. We will copy in our requirements, in this case, scikit-learn and Flask, and then run pip install these requirements, and then also copy in the files we need and do the exact same thing as we did before. Yeah, if we run this, you also notice a -p. This is because Docker doesn't expose any ports and you should explicitly tell Docker to do so. So in this case, we map port 5000 inside the container to port 5000 outside the container. Here you go. I could have just had copied the slides, but this is really what happened. So now we would like to talk a bit about how can we actually say anything about this image? How can we scan this image? How can we analyze this image for security vulnerabilities? And there's many tools available for this. There's tools that do dynamic analysis, so it looks at your running containers and verifies if there's anything going wrong, or we can use static analysis. So before we even run our image, we can also do some analysis on the file system itself inside this image, because in the end, an image is simply a zip file. So we use Claire. Claire is a way to perform static analysis, and I like to reiterate, this is not the way to do it. There's many ways you can do analysis, and in this specific example, I really like using Claire, and there's a nice integration called Claire Scanner. And Claire Scanner basically allows you to run Claire in the background, and then you can perform a nice little command, and here we simply specified which application we'd like to scan. Now this is the result. So we see vulnerabilities based on severity. This is for the Python 3 image we used earlier and what we put on top. Now, this doesn't necessarily mean that the Docker container we're using is vulnerable or it's unsafe to use. However, as a larger organization and compliancy and whatever, you don't want this. You don't want to explain this. So instead, what we could do is reduce our image. We can strip down this Python image we were using originally and take only the things we really need, which leads me to, so it also some nice other things is that, well, not so nice things, is that the size is quite large, 1.1 gigabytes. And someone can also attach a shell to this Docker container and execute commands inside this container. Now, this is difficult to prevent, but you don't really want this ever. So Distroless, right. So Distroless images are basically images that try to have the most minimal set of absolute needed applications, services, dependencies, such that your application can run. This is a quote I took from Google Container, the Distroless repository. And here they also mentioned that, okay, it doesn't have shells, it doesn't have package managers, etc. So I'd like to go further. I like to take the model we had earlier and now use a Distroless image. So if we do this, in this case, we use the Google supplied Distroless image. This is not the image to use. Most of the time, you would actually want to make your very own image. You would want to make your own Distroless image. But for these slides, I'd prefer to show a quick example. So here we use the Python 3 Distroless image. And when we run pip install, you'll notice that pip is not found. So because we don't have a package manager, suddenly it's more difficult to get these dependencies in there. Now, thankfully, Docker has a very nice way to solve this issue. We could use multi-stage builds. So a multi-stage build is simply where we take one image, we take one container, do all the stuff there, and then have another container and copy all the files over that we need into the new Docker file. And that looks a little something like this. So we take, again, a Python version. In this case, I'll use Python 3.5 to be more specific. We copy in the requirements again, and now we can run pip install because Python is originally installed in our bigger base image. And then again, we use the Distroless image, but instead of running pip install, we copy over the files inside the other image into our newer Distroless image. Because these Distroless images are so small, we might run into some configurational issues. So here you also see that we have to set some flag for UTF-8, otherwise Flask won't run. Not so nice. But yeah, if we scan this now, we get this, which happens if you use PyPlot and you don't plot any data. That's because there's no vulnerabilities. That's not to say that this image is super safe and you should totally use it, but it's nice because if Clara would find one vulnerability, the noise is kind of gone. A noise turns into a signal. We can use this signal to see what's wrong with this image. And furthermore, this image size has been reduced quite a bit. We've gone from 1.1 gigabytes to 250 megabytes, which is quite a significant reduction. And also, manipulating this container has become a bit more difficult because now we certainly don't have all these nice helper commands inside our Docker image. So as you can see, we can still attach a shell, but list files is not found. But we can do a bit better, and this is a bit experimental, and we could perhaps make it an even smaller image, because Python modules themselves could be vulnerabilities. What if we just also, instead of reducing the set of Linux dependencies or Python dependencies, we also reduce the modules themselves? So for this, we can use PyInstaller, for example. And this is a bit experimental, like I said, because PyInstaller is a bit difficult to work with in a production environment. And it also generates executable files, which might flag some security scanners, as the pattern PyInstaller generates flags some security tools because it's been used a lot maliciously, sadly. So coming back to that, a small change here. I didn't really like the Flask run bit, so I just created a main method. And yeah, so now it's important that we also upgrade pip. It's important that we upgrade setup tools for PyInstaller at least. Otherwise, we get into some issues that the existing dependencies in the Python 3 container fill. Now, if you run this, we sadly run into an issue that PyInstaller doesn't always spot all dependencies. So here you see that Siphon Blast is not found. Now, this is a bit difficult because we can't keep going on and specifying all the missing dependencies. However, in this case, I did do that. So we can help PyInstaller a bit by giving a specification file. So here you can see that we help PyInstaller find some missing dependencies. In this case, we've got I went through the process of running it 5 times, and every time it gave me something missing. So in this case, you can see that I specified some more files, and now we run it. All works great. And suddenly the image has shrunk even more to 97 megabytes. Now we can keep going on and on and on, because we can also perhaps strip down the Distroless image itself a bit more. We could only package Python inside our PyInstaller, but this becomes quite a complex process. Yeah. So we can use that's called a scratch image, where you completely build your own Distroless image all the way from the start. So lastly, some Docker tips. I've been running my containers as root. This is not smart. Don't run your containers as root. Please don't do that. That's perhaps the most important thing before even considering going to Distroless. Don't run as root ever. Also use image hashes instead of tags. So use the SHA digest instead of Python :3. Use the hash that you can find online in your container registry. And don't use the existing Distroless images. Build your own Distroless images. And building your own Distroless images is quite a hassle, but that's a talk on its own. And also, perhaps if you're a larger organization, you might want to sign your Docker images, validate who made these Docker images, so that you can verify that these images are actually made by someone within your organization. So to summarize, be very careful in which images you choose for your models. You don't want to use any model, you want to be any container. You want to be a bit more careful about this selection. You might want to make your own images to ensure that this is in control. And yeah, by using Distroless images, we limit the surface on which we have vulnerabilities. So yeah, thanks so much. Here are some of the tools I used. Yeah, that's it.
Right, fantastic. Thank you so much. Do we have any questions? Hi, thank you for your presentation. I wanted to ask, what if it will be really hard to strip out of our dependencies? Because if we include the NumPy, then we have to have installed the BLAST for it to work a little faster. And can we even do something then to strip it all? Or?
So yeah, you could entirely build your own Distroless images from the ground up. And this is quite difficult because someone has to manage this, right? If you're in a team, someone has to take this responsibility of making sure this image is up to date. It's in the end, an image is just a massive zip file with just an entire file system. It's definitely possible to make these very minimal machine learning Distroless images, which are specialized for perhaps TensorFlow or NumPy. But again, it's a lot of effort, but it's definitely possible. But this little side effect where you need someone to manage this.
Oh. Okay, thank you.
Hello, thanks for the presentation. One question, you suggested using image hashes instead of tags.
Yes.
Why is that?
So right now, if I take Python version 3 from the Docker Hub, I wouldn't know which Docker image I'm using. It's for reproducibility. So someone might update Python 3 because so someone might push a new image to this so-called version and a name of the image. So what will happen is that maybe it will work once, but someone pushes a new version, and I run it again, and it doesn't work anymore because something changed in between. But if you use the hash, you only point to the specific version, specific build of this image. Does it...
Thanks for the talk, very interesting. What do you think about Alpine-based Python images?
Yeah, so Alpine are very small images, very nice. They actually get pretty close to what the Distroless GCR images offer. I also ran some scans on them. They also contain very little vulnerabilities. I wanted to maybe show some also in the slides, but Alpine images are also really nice. They are not Distroless, but they are very small. So I guess if you cannot use Distroless, perhaps use Alpine images or smaller images like Python 3 Slim, which are just reduced images. But yeah, I do like Alpine images and I use them personally. You can definitely use them, but they're not truly Distroless in the sense that you completely strip out everything that's needed, because inside Alpine images, there's still a shell, there's still all of these things you need to have some functioning operating system. And they also have vulnerabilities, of course. Like recently they had this thing where shadow, where you could become root inside your Docker container.
Any more questions? Okay.
So I wanted to ask, so when you mentioned like building it from scratch, how different it is to build it from scratch than from a Distroless image? Like what more does the Distroless have?
So the Distroless has a lot of nice things, like SSH stuff, like certificates, users, privilege, a lot of very nice features. And if you were to have to use them, get them yourselves, then there's just a whole list of things you would want to copy inside your from scratch image. But it doesn't stop you from making a scratch image and just really carefully looking through what you need. So do you need user privileges? Yes, no, and just slowly build this list. But if you were to use a scratch image, then you can still use a multi-stage build where you build all the things you need, copy them inside your scratch image. But like I said, you need someone to really maintain this. It's a large job.
Thank you for the talk. One more question, if you don't mind. So I think we understand, like, it takes a little bit of additional effort to slim down your image and also to secure it. But in an enterprise environment, like, what's your perception? What was your experience? What's the right balance between taking that additional effort and like, would you just take it to step 3, or what, like, was there like a step?
Yeah.
Step 2, step 3. Where would you stop? Like, what's the right balance?
So I think the right balance is for a larger organization, for sure, to have their own managed Docker containers, their own base images or Distroless images, whatever you want to call them, as they have the resources to do so. And for compliancy, for all these other things that come with larger organizations, you definitely want at least these images to be, well, not the PyInstaller thing, because that's kind of experimental. And also, you would use your own Scratch images, because you need to know what goes into this image, and you need to be very strict on what is allowed in this image and what's not allowed in this image. So for large organizations, an own team is.
Okay, thank you. Do we have any more questions? Yes, we do.
I'm just curious what kind of use cases you're deploying these machine learning solutions for. ING is a bank, right? So yeah. Can you tell me a bit about that? So I presume it's hosting some kind of API that is called and returning.
Yeah. So we have a machine learning platform, and on this platform, you will be able to approach. Say like, okay, I want this model. I do this prediction with this model. And we could be running tens or 100 models at the same time. But the use cases for these models vary extremely. For example, we could be looking at some natural language processing, or they for a bank, they are all over the place. I could go into very specific details, but then I can talk to you after.
Yeah, maybe we talk after.
Yeah, okay.
Thanks.
Okay. Any more questions? Okay, then let's give another round of applause for Thomas.